RAID 0. User and system data are distributed across of the disk in the array. The data are striped across the available disk. RAID 1. Redundancy is achieved by the simple expedient of duplicating all the data. Mirroring for fault tolerance. RAID 2. Typically, the spindles of the individual drives are synchronized so that each disk head is in the same position on each disk at any given time. Uses parallel access technique. An error-correcting code is calculated across corresponding bits on each data disk, and the bits of the code are stored in the corresponding bit positions on multiple parity disks. Typically, a Hamming code is used which is able to correct single-bit errors and detect double-bit errors. RAID 3. A disk subsystem that increases safety by computing parity data and increasing speed by interleaving data across two or more drives. Employs parallel access with data distributed in small strips, speed and fault tolerance.
RAID 4 consists of block level stripping with dedicated parity. This level was previously used by NetApp but has now been largely replaced by a proprietary implementation of RAID 4 with two parity disks called RAID DP. The main advantage of RAID 4 over RAID 2 and 3 is I/O parallelism. In RAID 2 and 3, a single read I/O operation requires reading the whole group of data drives, while in RAID 4, one of I/O reading operation does not have a spread across all data drives. As a result, more I/O operations can be executed in parallel, improving the performance of small transfer. RAID 5 consists of block level stripping with distributed parity. Unlike RAID 4, parity information is distributed among the drives, requiring all drives but one to be present to operate. Upon failure of a single drive, subsequent reads can be calculated from the distributed parity such that no data is lost. RAID 5 requires at least 3 disks. Like all single parity concept, large RAID 5 implementations are susceptible to system failures because of trends regarding array rebuild time and the chance of drive failure during rebuild. Rebuilding an array requires reading all data from all disks, opening a chance of a second drive failure and the loss of the entire array. RAID 6 consists of block level stripping with double distributed parity. Double parity provides fault tolerance up to 2 failed drives. This makes larger RAID groups more practical, especially for high availability system as large capacity drives take longer to restore. RAID 6 requires a minimum of 4 disks. As with RAID 5, a single drive failure results in reduced performance of the entire array until the failed drive has been replaced. With a RAID 6 array, using drives from multiple sources and manufacturers, it is possible to mitigate most of the problems associated with RAID 5. The larger the drive capacities and the larger the array size, the more important it becomes to choose RAID 6 instead of RAID 5.